All right, folks, welcome back to Moonshine Radio. Here we're looking at the spectrum analyzer again. And as you can see, there's something kind of blipping up and down in there, and kind of hard to tell what's going on. And that's one of the problems with these old frequency swept type spectrum analyzers. You see, when it's a nice constant tone like this, these old swept type of spectrum analyzers work really good. But the second you start putting some kind of modulation on it, that they're just not going to capture the signal too well. So what they have is what's called a real-time spectrum analyzer, and this actually has that. So now if we go into that mode, there you see the spectrogram. Here we have the density. So you see the pulse going on all the time. And there it is, just a nice tone. And here we are chopping it up, and you still see the signal. So this type of spectrum is not sweeping. It's giving in a whole bunch of data and doing an FFT as fast as it can. So there we got a little waterfall. There's a spectrum, and we should be able to even sweep even smaller, just so we can show you guys how good this thing is. All right. Now the y-axis is time, x-axis is frequency. So that's pretty darn cool. As you can see here, we can move the pulses around as I change frequency. You see that? Pretty darn nice. So we can clearly see this is a nice pulsed signal. We can measure the pulse width, look at the PRI, all kinds of stuff. So it's pretty nifty. And here's a nice power versus time. Here's a 3D spectrogram of the thing showing you that. And as I move the freak around, you see the frequency change in there. So let's us see the frequency as it hops around and dithers and does all kinds of fancy hopping, long as it stays within that 25 megahertz window. You can see all the hoppiness and the hopping. It's doing so much hopping, it's like hops in a glass of beer. All right, folks, thanks for watching Moonshine Radio.